Hi everyone. In this video I will be demonstrating how to perform a one-way analysis of covariance using SPSS version 28. And before I get started, I do want to mention that underneath the video description you'll find a link to the SPSS data file that I'll be working from in this presentation, so you can download a copy of the data to follow along. You'll also find a link to a supplemental PowerPoint that will go into a lot more detail that I'm going to be providing in this video presentation. Now, the example that I'm going to be covering is based loosely off of one that is given by Pittock and Stevens in their 2016 text, Applied Multivariate Statistics for the Social Sciences. But whereas they were focusing their discussion on ANCOVA, basically multivariate analysis of covariance, we're going to be focusing in on ANCOVA, basically where we have a single dependent variable. So let's go ahead and consider our data set. We have our independent variable in our analysis is going to be this treatment condition variable right here, and our dependent variable is going to be this avoid variable, and then our covariate will be this pre-avoid variable right here. So basically we have 33 cases. We could think of that as 33 individuals who were assigned to one of three treatment conditions. And briefly, we can just take a quick look at the treatment conditions. You can see that we have individuals in a behavioral rehearsal group, that's group 1, individuals in a control group, that's group 2, and then individuals in a behavioral rehearsal plus cognitive restructuring group, that's our group 3. And so what we're going to be doing is testing for differences in means between those groups on this measure of avoid right here. Now, just briefly, this avoid variable is actually scored in a way such that higher is actually better. It actually means better treatment responsiveness, whereas lower scores indicate poor responsiveness. So just kind of keep that in mind as we go through. So if we were just going to carry out a one-way analysis of variance, it would be very easy just by incorporating our independent variable treatment condition and our dependent variable avoidance. But what we want to do in this analysis is account for pre-treatment differences in avoidance. And so that's where this pre-avoid variable comes in as a covariate within our model. So let's go ahead and run our analysis. We're going to go up to Analyze, General Linear Model, and to Univariate. We're going to move the treatment condition variable to the fixed factors box and avoid to the dependent variable box. And we'll move our covariate, pre-avoid, down to the covariate box. We'll select options right here, and there are various things that we can ask for. I'm going to go ahead and select descriptive statistics, estimates of effect size. We can ask for observed power if we want. I'll go ahead and select parameter estimates. We don't oftentimes see folks going too far into that level of detail when reporting on ANCOVA results, but it's still worth knowing something about. And we'll also click on homogeneity tests to test the homogeneity of variances assumption. Next, we'll click on Continue, and then we'll click on Estimated Marginal Means, this EM Means tab right here. And we'll move it over to this box for Display Means for. And one thing that I want to draw your attention to early on in this presentation is that what we're going to be doing when we test for mean differences is we're going to be testing for differences in adjusted means. That is, the means on the dependent variable that are adjusted for any differences that might exist on the covariate. So those are adjusted means. So when we requested descriptive statistics under the Options tab, we're going to get a table that contains group means, but those means are not adjusted for the presence of the covariate. And while it's fine to report on the unadjusted means in any report that you might put together, it's going to be extremely important that you report on the adjusted means as well. And so this is how you're going to be able to generate those adjusted means. Now, while we're under this tab, we're also going to click on Compare Main Effects, and I'm going to go ahead and go down here and select Bonferroni. So one of the things that you'll find when you're running an ANCOVA in SPSS is this little box right here for post hoc is not lit up. That means you don't have an option for requesting something like Tukey's post hoc test or anything of that nature. And if it's the case where you want to perform some type of pairwise comparisons after the main analysis, such as Tukey's or whatever, you don't really have anything available to you through that menu. But we can generate something reasonably effective by going under and essentially clicking on compare main effects. So we'll get pairwise comparisons, and then if we click on this Bonferroni right here, we can get those pairwise comparisons with Bonferroni adjustments. So just keep in mind that Tukey's is essentially a test designed to deal with the issue of type 1 error inflation as a result of multiple tests, and so it's using a family-wise type 1 error procedure. And over here instead we're just using a Bonferroni adjustment right there, which seems pretty reasonable as a way of keeping type 1 error rate in check. So anyway, we'll go ahead and click on continue, and under plots we can move our independent variable over to the horizontal axis box and click on add. And we have a couple of chart type options. I'll go ahead and select bar chart right here, and if I want to, I can also request error bars right here. Just by default this is going to get me error bars for the adjusted means. Essentially the first one is a confidence interval around those adjusted means, a 95% confidence interval. So we'll click continue. And one other thing that I want to mention before we actually press the OK button and generate our output is that under this model tab right here, you'll see that there's not really a whole lot we're going to do with it right now, but I do want to draw your attention to one thing, which is at the bottom right here you'll see it says sum of squares type, and it says type 3 sum of squares. So this is what I demonstrate throughout much of the PowerPoint presentation I was referring to, but I do include an appendix at the end where I use type 1 sum of squares approach, and so I do discuss situations where you might want to use a type 1 sum of squares approach instead. So just kind of keep in mind there's reasonable debate on that issue, but by default it's going to use type 3 sum of squares. It's always defaulting at some type 3 sum of squares when you're running any kind of analysis through SPSS when you're using the univariate approach or the general linear model approach. But if you want to make that change to type the sum of squares, all you have to do is just kind of use the drop down and make that selection. So at this point we're going to go ahead and click on, actually let me check one more thing. One of the things that I do want to draw your attention to, this may be an issue for you, it may not be, but for me it seems to be that sometimes, I don't know why, but some of the options that I've selected previously kind of reset to not being there. So I'm going to have to reset this again. Looks like just kind of doing a couple of those other menus kind of caused this to reset. So we're resetting this again, and we'll click on OK to generate our output. So looking at our output, you can see we have a table of descriptive statistics. We've got the means and standard deviation sample sizes for the behavioral rehearsal, the control group, and behavioral rehearsal plus cognitive restructuring group. So you can see that the highest means are for the behavioral rehearsal plus cognitive restructuring, followed by the behavioral rehearsal, followed by the control group. So again, even though the variable is called avoid, I can only assume that higher is actually referring to better treatment responses, because individuals in the control group would have not received a treatment, and so so there you go. So that's something to keep in mind. Now also note that these means are unadjusted means, as I was saying before. So when it comes to reporting your results, it's fine to report on these, but you need to be sure to also report on the adjusted means. And of the two, if you had to pick one set or the other, go with the adjusted means. But a lot of folks will probably just want to report on both sets of means. So the adjusted means are not in this table. I'll show you where you can find them in a second. So we'll scroll down a little bit further, and you can see that we have Levine's test of equality of error variances. So one of the assumptions of this procedure is that the residual variances are equivalent across our groups. Okay, and so if we have a violation of that assumption, that can sometimes translate into an increased type 1 or type 2 error risk when it comes to interpreting our effects during the ANCOVA. So what we can look at right here is the p-value that's given. It's 0.407, and what we're looking for basically are p-values that would be greater than 0.05, and that happens to be the case right here. So based on this result right here, we would conclude, at least based off of this test, that we have equality of error variances assumption being met. If the p-value is less than 0.05, then that would call into question that assumption being met for our analysis. So we'll scroll on down a little bit further, and you can see that we have our ANCOVA table. Basically, our ANCOVA results are contained in this test of between subjects effects, and you'll notice that we have the independent variable, treatment condition, and we have the covariate given right here. So with respect to our independent variable treatment condition, you can see there's our F value and our significance level that's given, and you can see that we have statistically significant differences among our adjusted means. So keep in mind, the test is testing differences in adjusted means on the dependent variable, and so in this case that seems to be the case right here. And so you may also want to report on effect size. So you have over here, we've got the partial eta squared value that's given. So using Cohen standards of around 0.01 as an indicator of a small effect, around 0.06 as an indicator of a medium effect, values around 0.14 or greater would indicate a large effect, we would conclude that we have a large effect of treatment condition with respect to our dependent variable. Then you can see that we have our covariate that's given right here, and there is a test of the covariate in terms of statistical significance. So you can see that we have statistical significance for pre-avoid, and that's going to basically be indicating that there's a significant relationship between the pre-avoid scores and post-treatment avoid scores. And when it comes to the partial eta squared value, you can see that we have a 0.614, which would also suggest a large effect with respect to the covariate. And that's not a big surprise, because the assumption in this case is that we have the same measurement or the same measure of the avoid variable. It's just one is measured prior to treatment, the other one is measured following treatment. So we'll scroll down next and go down to the parameter estimates table. And so this table is essentially a reparameterization of the ANCOVA in the form of a linear regression. So as you're looking at the results, they're going to mirror what we have above. But just to kind of talk a little bit about what these things are, you'll see that we've got a column containing regression coefficients. We have a column containing standard errors and t-values, and then significance levels. So first off, you'll notice that we have an intercept. So the intercept in any regression model is the predicted value on the dependent variable when all of your predictors are equal to 0. And so that might or might not be relevant or even interpretable if you have values on predictor variables that kind of fall outside, where 0 does not fall within the observed range of values. And that actually tends to be the case right here with our pre-avoid variable. That doesn't really make a whole lot of sense. Nevertheless, that's just kind of telling you a little bit about what that is. The pre-avoid variable, we have a regression slope right here of 0.699. So you can see that this is telling us that we have a positive predictive relationship between the pre-avoid and the avoid variable. And the significance level that's given right here is exactly the same as what we have in the table above. It's literally the same test that's being carried out. It's just in this case, it's in the form of a t-test, whereas up above you'll see it in the form of an f-test. Now, in this next portion of our output, what we have is treatment condition, and you'll see we've got treatment 1, 2, and 3 that's kind of showing up in the output. But in a nutshell, what's gone on is that the program has taken the original treatment variable, which was coded 1, 2, and 3, and dummy coded this variable, or essentially converted this original variable into two dummy coded variables. So the first dummy variable, we have a dummy variable and 1 and dummy variable 2 right here. We'll just call it that. And the coding system as it's given, you'll see that basically the third group is being treated as a reference category, and that's why there's no regression coefficient for that last line in the parameter estimates table. So this group right here is actually coded 0 on both of these dummy variables. And then the first group is coded 1 on the first dummy variable and 0 on the second one. And then the second group is coded 0 on the first dummy variable and 1 on the second. And so what you have then in the form of these regression coefficients are computed differences between the mean of, say, group 1 and group 3 and between group 2 and group 3. And so given that those regression slopes are negative, what that's actually telling us is that the means in groups 1 and 2 are less than the mean for group 3. So at any rate, that's kind of the parameter estimates table in a nutshell. Obviously, I haven't gone through the entire thing, but it's just basically, again, a reparameterization of that ANCOVA in the form of linear regression. Now, when we scroll down a little bit further, you'll see that we've got our estimated marginal mean. So the first off, keep in mind that when we are controlling for the covariate, we are essentially computing means, assuming that, essentially at the mean on the covariate. So the mean on the covariate, the pre-avoid variable that you see right here, is 106.6970. And so the grand mean on that variable is this 118.364. Again, it's adjusted for the covariate. Then we have the group means, the adjusted group means. So down here in this portion of our output, this is where you're going to find the adjusted group means. So in a nutshell, these are those adjusted means, and again, this is extremely important that you be sure to report on those adjusted means. So you can see right here it says covariates appearing in the model are evaluated at the following values, and it's again at the grand mean on the covariate. So the basic idea is that when we were carrying out the analysis of covariance and we were testing the differences among the groups, what we were doing is statistically equating the groups at the mean of the covariate, or the grand mean on the covariate. And again, that's the reason why we want to be sure to report on these means when we are talking about our ANCOVA results. Now when we scroll down a little bit further, you'll see that we've got a table containing pairwise comparisons. And so in this case, we have comparisons between the different adjusted means in this table up here, the table of estimates. So you'll see first off we have a comparison between the behavioral rehearsal group and the control group right here. So if I take the mean for the behavioral rehearsal group, subtract the mean for the control group, I get this difference right here. And so you can see it's just I minus j. So the behavioral group minus the control group, well, you can see the mean for the behavioral group is 119.365. The mean for the control group is 108.302. So if I take the former and subtract the latter, that gets me the mean difference of 11.064. But you can also see that this difference is not statistically significant. Then, if we want to compare the behavioral group right here versus the behavioral rehearsal plus cognitive restructuring, in that case, it's going to be taking the adjusted mean here and subtracting the adjusted mean for that group 3, and that's what produces this negative value in terms of the mean difference right here. So you can see that the difference in those adjusted means is about 8.058, with the larger mean being associated with the behavioral rehearsal plus cognitive restructuring group. You can further see that the difference in those adjusted means is not statistically significant. And then when you look at the comparison between the control group and the behavioral rehearsal plus cognitive restructuring, in this case right here, it's just the 108.302 minus 127.424, and that's this comparison right here. So there's the difference that's computed between those two adjusted means, and you can see that that difference is statistically significant. So in a nutshell, if I take the mean on this avoid variable and subtract the adjusted mean for the cognitive behavioral versus the behavioral rehearsal versus cognitive restructuring mean, then that's what gets us this 19.122. So we can further kind of look at our output by scrolling down, and we can see that we have the estimated marginal means of a void, basically in a profile plot. So this bar plot right here, you can see that the highest bar is associated with the the behavioral rehearsal plus cognitive restructuring. The second highest bar is for the behavioral rehearsal, and then the third highest bar is for the control group that you see right here. Okay, so briefly I want to transition a bit. I'm going to go back to this parameter estimates table just to show you how you can generate the same results using linear regression in SPSS, just to kind of further demonstrate the equivalence between those two outputs. So to accomplish that, I'm going to go back into the actual data set right here, and in SPSS version 28, what you'll find is that there's a nice little tool that will allow you to generate dummy coded variables. So we want to dummy code this treatment condition variable right here. So to accomplish that, we can just go under transform and click on this button for create dummy variables, and we'll move the treatment condition variable over to this dummy variable box right here, and we can establish a root name. So I'll just call it dumb for lack of a better way of naming it, and then we'll click on OK, and you'll see in the data set now there's 3 dummy variables that have been created, and we're only going to be using the first 2 dummy variables. We don't want to run a regression analysis with all 3 because of basically dummy 3 is collinear with the other 2 dummy variables. So I'm going to get rid of that altogether, and you'll notice that in terms of the coding system, we've got treatment condition 1 is coded 1 on the first dummy variable and 0 on the second. Treatment condition 2 right here is dummy coded 0 on the first and 1 on the second, and then treatment group 3 is coded 0 across both dummy variables. So again, all of the grouping information is contained in those 2 dummy variables. So if I just carry this analysis out just by running a linear regression, I can move the pre-avoid variable over to the independent box along with the 2 dummy variables, move them over, and then if I move the avoid variable over to the dependent box and click on OK, well, basically then we have the same results that are shown down in this coefficients table. So the intercept right here, which in this part of our output is named constant, but it's the intercept that we saw previously. You'll see that we have the regression slope for pre-avoid right there. That's the same as what was in our parameter estimates table, and then you can see both of those regression coefficients representing differences in adjusted means between group 1 and 3 and 2 and 3, and so those are exactly the same as what we had seen before. Okay, so that pretty well wraps up this video presentation on one-way analysis of covariance using SPSS version 28, and I appreciate you watching.